All right, hi everyone. I gather we don't have a PA system. I'm just speaking in there for the camera. If you can't hear me, please shout in the back. Yeah. All right, we're going to talk about GStreamer. Catchy title. It's going to be super high level. If you're hoping for any in-depth information about GStreamer, you're not going to find it here, but you can catch me in the hallway later and we can talk about anything. Right, I'm Tim, that's Sebastian. And well, first of all, who are we? We're long-time GStreamer developers. We've been hacking on it for 10 years, roughly. We work for Centricular, which is a new little startup consultancy, and we do consulting around GStreamer, multimedia, and graphics stuff. So what are we going to talk about? First of all, quick intro to GStreamer. What is that thing? Secondly, the biggest part, we're just going to, as I said, very high level, just mention different things people are doing with GStreamer. And then at the end, we're going to talk about a little bit about sort of what's coming up, what are people working on, what features do we expect to land soon, maybe what's missing as well. Right, so GStreamer, what is it? It's a multimedia framework. It's pipeline based. That means there's a concept of a flow, you know, something produces certain types of media, and then you have a pipeline, and you have building blocks, and you put them all together, and then somehow the media flows from one to the next. And all these building blocks have different functions. So you might have something that, you know, outputs stuff to the screen, or it writes it to a file, or it, you know, scales it, or transforms it, or applies a little funny hat effect, or whatever. All these things. And it's very much like Lego. You know, you just have all these different pieces, you can put them together, and then you just say, go, and it does stuff. So basically what it provides is it's all plugin based, so you can write your own plugins. There are hundreds of different plugins. But GStreamer itself is a library, so you can use it in your application like everything else. So you use all these plugins, you as Lego pieces, you build your Lego thing, and then you just set it to play. And we try to be super generic, so we build on other people's work. Like for codecs on the Linux desktop, for example, we would use libav or ffmpeg. We wrap other people's libraries and other people's multimedia work, so it's not like we reinvent everything from scratch, but we just provide the framework and let the hard work, leave that to other people. It's open source, LGPL2, which means you can write proprietary applications on top of it. You don't have to publish your code. You can write proprietary plugins and keep them to yourself. Although, you know, making them open source is always nicer, but, you know, sometimes you can't. So that's proprietary stuff, perfectly fine. It's cross-platform, Linux, embedded Linux, Android, iOS, Windows, OS X, you name it, we've got it. And we've got binaries for it as well. It's a stable API. We guarantee backward compatibility. And we have, you don't have to write everything in C if you don't want to. We provide bindings for high-level languages, Python, JavaScript, whatnot. Just to make that point clear, things GStreamer is not. It's not a server of any kind. It's not a media player. It's not a transcoding tool. It's not a, you know, it's not a codec or a protocol library. You can use GStreamer to do all of these things, but it's just a library for you to do anything multimedia related. And our goals are we want to be super flexible. Like we want to integrate with everything and everyone. Both of you know, you should be able to use more or less anything in you know, as a plugin in GStreamer. But likewise, you should be able to use GStreamer in anything you do, whether it's a web browser, whether it's you know, a server application you're writing, whether it's a little handheld device thingy you're writing, whatever. It should, you know, it should work everywhere. We shouldn't say, okay, but only if you use that toolkit and that. You know, we try to work everywhere. We have a super large active developer community. I think we've got a great community. So whenever you have a problem, chances are there are loads of people who've run into it already, which is great. And we also have a large commercial ecosystem. There are loads of companies building products on top of GStreamer. And even more importantly, these companies, they don't just take the stuff and go away and do their thing, but many of them actually, I mean, there are loads of those as well, of course, but many of them, they actually contribute back. So you've got companies which contribute fixes and code all the time, which is great. And of course, you've got consultancies as well, not just one, multiple ones. That's always good to have if you're building stuff. All right, over to Sebastian.
Okay, hello. So let's start with the stuff people are doing with GStreamer. First, let's start with the boring things. Like it's used in desktop environments and desktop applications. If you use Linux, you probably use it somewhere. It's used by GNOME, Enlightenment, XFCE, KDE. Used for media players, screen capturing, camera usage, all the stuff. It's used by Qt, by the Qt multimedia subsystem. It's used by the OpenJDK. It's used by LibreOffice, OpenOffice. So whatever you have on your desktop, you probably use it, at least on Linux. And well, this kind of stuff was where GStreamer found its first large-scale usage. But as said, that's boring. Let's go to the more interesting things. So let's go to the web. It's used in WebKit in 4 different ports at least, in the GTK, and the EFL, in the Qt, and in the Windows Cairo ports. And there it's used for all the HTML5 media stuff. It's used for media source extension. It's used for web audio, for everything basically. It's also used in Firefox. Not that much there. They're just using it as a codec library. I think by default on Linux, and you can compile it on OS X and Windows, but it's not the default. And then since a few days there's a Blink extension, a Chrome extension, where you can then just use GStreamer to do all the stuff, all the media stuff in the browser instead of whatever Google is providing you. And then there's a new WebRTC client-side implementation since last year October called OpenWebRTC, which is also just wrapping around GStreamer. And well, it's a very little code base. I think it's something like 10,000 lines of code, and all the heavy work is done by GStreamer. What they provide is sample applications for Linux, Android, iOS, and OS X. Currently it's work in progress, and soonish there is integration into WebKit planned. Then on the server side, of course, we also have quite a few applications there. Most important, let's say, Currento currently, which is a WebRTC HTML5 streaming server thing. It's huge, it's very enterprisey, and you can basically do everything with it. But we also have smaller things like all kinds of little streaming transcoding servers that are built on GStreamer. We have our own RTSP server implementation. We have stuff for Dash and HLS. You can even buy some commercial hardware boxes where you plug in some inputs and it's just encoding stuff and sending it to the network. Then what we also have is a DLNA server implementation called Rigel, which exists since quite a few years already, works quite well. And it's using GStreamer for example for transcoding on the fly. If your device can't handle a specific codec, well, it's just transcoding on the fly. You don't notice anything, it just plays afterwards. Then to a few more interesting things. It's used in video editing applications. So what you see here is, well, standard nonlinear video editor interface. This is a PTV open source application, and it's using GStreamer for all the media handling, for the editing, for the encoding, for reading of files, for effects. And well, there's currently a fundraiser still running if you want to donate some money on it, so it becomes even better. And in the end, it's all the work that is done on PTV is also helping GStreamer in general. And PTV is based on the GStreamer editing services library, which, well, is, as said, used in PTV, but it's also used in quite a few commercial products nowadays. So there's, for example, this one here. It's an application where you can, you have recordings for a movie from different angles, etc., and you can just align them properly, then select, oh, I want to have this part for the first 10 seconds, then from this angle the other seconds, and it allows you to, well, combine all this movie. Then it's used in music compositing and audio editing applications. So one of them is bus tracks, and it allows you to put together various instruments graphically, and then you can define control curves for all kinds of properties on them, and then let that thing run. So maybe a picture says a bit more. Basically, you have all kinds of virtual electronic instruments like oscillators, all kinds of filters, and then you can just plug things together and make cool electronic music.
There's one thing people use GStreamer for quite a bit. It comes up in loads of different scenarios, which is multi-device synchronization. You will notice we'll mention it multiple times. One of them is, for example, you've got a classroom thing, you know, like everyone has tablets, the teacher has a tablet or a computer, and you want to stream that to all your students, and the students should sort of be able to follow what the teacher does, or likewise. You will think, okay, you know, a picture, 50 tablets, a solved problem, you know, just use multicast or whatever. It's in theory quite simple, but in practice it's a little bit tricky because you've got Wi-Fi, so, you know, Wi-Fi. You can't use multicast in practice. You deal with random access points and infrastructure that you don't control the hardware of. So it's quite challenging. You've got bandwidth is very limited. You've got all these different devices. It has to work with all these different versions, etc., etc., etc. So it's quite tricky to do in practice. That's what it looks like. You know, about 50 or whatever, 30, I don't know, haven't counted tablets. That's what it looked like before, and later they're all in sync. And I can't show you the video now, but if you look at the video, it's quite nice. You know, the teacher goes like, does stuff on the tablet, and you can see how it, with very low latency, sort of updates on the other bits. That's for you.
Yeah, then what's relatively new is that GStreamer is used in quite a few commercial ingest or playout servers. Basically what the goal is, you have all kinds of inputs. You want to record them live, you want to broadcast them, you want to mix them together. And in all that, it's very important that you have some fixed defined latency, and things just shouldn't fall apart. And especially everything has to run reliable for 24 hours, 7 days a week. It just must not fail. And well, there are a few applications that are doing this, or stuff like scheduling of recorded shows, overlaying things, putting subtitles in there, or some kind of news sticker. Some of them are using the GPU for all this fancy mixing stuff. And what is also important here in this context is, well, we have good support for SDI input and output for 4K, 8K, 10-bit, 12-bit video. It's all there. Currently best supported would be the Blackmagic decklink cards, but also we support quite a few others. And well, that's how you could visualize that kind of thing. This kind of software could run GStreamer. Our example here doesn't, but others do. Then,
yeah. Just to go back to the server stuff. The problem in GStreamer is always you have these pipelines and you put stuff together, and then data, you know, buffers, video, audio starts to flow. And our problem has always been that, well, you know, if there's no data flow somewhere, then the whole pipeline sort of gets jammed. So it's quite recently we now have lots of video mixers and audio mixers which work very well with live input, which is something you need in that scenario. That's where the defined latency comes from. So that's in Git currently. That's quite nice. Of course, GStreamer is used on set-top boxes. There are different kinds of boxes. Some are just IPTV type things, you know, in hospitals. They just stream different TV channels over multicast or unicast over IP. Some are personal video recorders, of course, live TV, DVB. There's catch-up video, iPlayer and stuff like that, and also video on demand. Video on demand is basically, well, it might be for pay or it might not be for pay. It could be encrypted or not. Those usually use quite low-cost chips, which makes it sometimes a bit challenging. And there are loads of people who do set-top boxes using that. UView is one of them, which is like a BBC, not subsidiary, but company. Dreambox make Dream hardware. There's a French company which uses them. You know what a set-top box looks like. That's what it does. It's same for TVs. It's actually used quite widely in TVs. I think all the major TV manufacturers use GStreamer somewhere these days. LG does stuff with WebOS. Samsung has announced Tizen TVs now, which also includes GStreamer. That's quite cool. And I think GStreamer is mostly used in those cases for the connectivity part, which is basically DLNA playback of stuff from an external hard drive. The on-demand video, all these smart TV features, you know, like Netflix and Amazon and stuff like that, possibly.
Yeah,
So-
but also for recording and
Yeah,
time
sure.
shifting.
Oh, time shifting. That's what a TV looks like.
That's
You
used.
might have seen one before. And of course, then you've got all these integrated entertainment systems, which is airplanes, cars, etc. In-flight entertainment, in-vehicle entertainment. Again, you have video on demand. You know, if you're in a plane, of course, you just choose what to play. In a car, you might want to share your screen between different users, and your network connection is limited, so you can't play the same clip 3 times and download it, but you have to download it once and share it out and things like that. And again, synchronized multi-device playback. You know, you have a security announcement and blah 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 in your, at the beginning of the flight, in your plane, and you want it to be played on all 180 seats in sync. Apparently, it's quite challenging. I don't know. I have been on a new plane recently, and the sync was out for 5 seconds. It's amazing. Boeing 777. It's also used in little planes like that, like a Challenger plane or Learjet or something, business plane. So the entertainment system there uses GStreamer. Just do that.
Yeah, then it's also used for video walls or distributed speaker systems. And in those cases, it's always important that you have, well, for the video, frame accurate synchronization between all the different devices. For audio, well, you need even more accurate synchronization, and well, we can do that over the network. And there's also a little, well, example demo application called Arena that you could use to set this up in your own network and just play around with it. If you look at the code, it's really small, and it's allowing you to, well, show the same video or audio on a lot of different devices, and it's completely synchronized. There's also an Android application using that, so you could even use it on your phone or your tablet. And there are also well, quite a few commercial products used for control rooms or, well, command rooms, for video walls, for digital signage. And, well, also for this kind of huge control room things. It's quite amazing what people are actually doing.
Drones, yes. Well, most of them, if you watch Homeland, it's all military and espionage use, but actually increasingly people are using drones for all kinds of civil use cases. And they're doing stuff with GStreamer on them. I mean, so rescue and emergency stuff, it's both sort of, I don't know, well, you could deliver medical aid, for example, or you're in disaster relief, remote areas which you can't easily access. It's used apparently for law enforcement, I've been told, in the US, along roads in the middle of nowhere where they enforce a speed limit using that. Packet delivery, we have to see.
Yeah, and also it's quite interesting. It's used in a few places, in remote places, to well, to make sure that no fire is happening there or no other disasters. So if you have a huge jungle or a huge, how do you call it? Steppe? Well,
Right. Augmented reality, yeah. So this is a demo. I don't know. It's very hard to see, but so you've got a guy here, and one of these Oculus Rift kind of things. So it's basically, you get to see stereo video. You got a stereo impression, and the camera is on the little digger. It's like a digger, sort of an excavator. And the idea is that the guy with the glasses sort of remote controls the excavator. And of course, that needs to be very low latency. It actually uses WebRTC in this case, so that's quite nice.
well, we don't have that much time anymore, so I will skip a bit. But well, I'll just say a little bit about these things. It's used in all kinds of home security systems, for security cameras, for, well, motion detection. You just want to start recording once something is moving. It's used for, well, streaming these things, so you can, well, observe your home when you're in your holidays and stuff like that. Then it's used actually quite a lot for all kind of IP conferencing and communication, and in those cases, very important, absolutely low latency. You want to have all this kind of stuff work with lots of participants. And there are a few commercial products that are doing that at a very huge scale. And things like WebRTC or SIP are, of course, used in these cases and perfectly supported. Then what's also quite nice is it's used for event recording and broadcasting. So for example, there's an open source application called Tim Videos, not related to this Tim. And it was used last year at LCA for recording all the presentations and streaming them. But there's also a commercial company called Ubicast, which is providing services to record all kinds of events and stream them. And they are also using GStreamer inside a proprietary application. Then it's also used for media management and publishing. There's the Media Goblin open source project, for example. Basically what it allows you to do, deploy your own YouTube, Flickr or SoundCloud kind of thing. It is or was, we're not completely sure, used by Ardu, which is some kind of Spotify-like service in the US. And they were or are using it in the backend for streaming. And then, of course, it's used in lots of mobile and embedded devices. As said before, it's used for iOS apps, for Android apps. But there are also actually some Android devices that included in the system. For example, the Samsung Galaxy X cover. So if you have that one, it's using GStreamer inside. You might not know. And it's part of lots of embedded Linux SDKs. You will notice it. Then, quite fancy thing, it's used for gravitational wave research for the LIGO project, which is for Laser Interferometer Gravitational Wave Observatory. I have no idea what that does exactly, but what they are trying to do is they are trying to detect gravitational waves from collisions or of neutron stars or rotating neutron stars. It's quite fancy stuff. And they have large-scale signal processing pipelines using GStreamer with thousands of filters, and they need perfect synchronization. If after 30 hours there's a drift of one sample, they will complain, and they fixed quite a few bugs like this already. And large parts of this are free software.
Right, and we had a guy who actually, well, I think it's just a little Android app, but he used GStreamer to put stuff on the International Space Station, little application for astronauts apparently to help them with different procedures on their smartphone, which is scheduled to go up. I don't know if it's up yet. Quick, the future, we don't have much time. What are we working on? What are we hoping to improve in the near future? Development tools, it's been one of our weak spots. There's a new tracing subsystem in Bugzilla. We still have to review it. Based on that, we hope that we'll be able to develop better tools for debugging stuff and tracing stuff and performance optimizations. Continuous integrations, builds for all operating systems exist already. We want to create binaries automatically. Testing, a lot of testing and QA stuff is going on. GST Validate is a new suite which is proving to be increasingly useful. GST Harness is a new API to create unit tests. On the feature front, sorry?
You missed one important point, the convenience APIs, because that's also what people are often complaining about, that it's so difficult to write a player and, for example, and we now provide more easy APIs to, well, you can write a playback application in 10 lines of C code.
I apologize. Features, trick modes. Trick modes is a big area. There are lots of different types of trick modes. The adaptive streaming type trick mode is sort of very important to many people, so that's being worked on. But also for local file playback. Stereoscopic 3D support, hopefully going to land soon. Editing support is being improved. Dash HLS, both the serving side and the client side are being improved. Cross-platform support, the other platforms, we're trying to get them up to, I mean, you know, all platforms should be the same level of quality, make sure the plugins work great, hardware acceleration should work, you know, on iOS and Android, etc., etc., etc. Yeah. Anything else? We might have time for one single question. Does anyone have any questions?
Thank you very much.
No time.
Impressive. It seems maybe GStreamer is just not doing coffee. That's the only thing it's not doing.
But
so
it can.
It can.
It could.
So we have time for one question.
You had a
wanted to
question?
ask a question?
Yes, I did. So you've mentioned that you're working on better debugging tools. It's not really development tools, like debugging tools. But if this is C, then why not just debug with, compile with debug information and use GDB or core dumps? I mean, what are your plans? What are you?
Well, I mean, those are sort of the easy things to debug. Sorry, the question was, why don't we, I was talking about better debugging tools, why don't we use just, GDB and the, Valgrind and all the usual tools for debugging? Yeah, I should probably have made that clear. The kind of debugging tools we're looking for are completely different from those kind of code debugging tools. If you have complex pipelines, you want to know, why does that take so much time? Do we do stuff efficiently, inefficiently? How long does it take for a buffer to go from there to there? What's the latency of certain things? Stuff like that. That's very, very hard to track down currently because you've got these huge complex pipeline interactions. Yes,
so
that's
plan on making such a framework that will allow to do that with.
Yeah, so you
the
can
G-
sort of
the
you
G-Stream
can
file.
set up hooks and you can sort of drill down to specific parts of the pipeline and sort of find out exactly what's going on. Currently, we have a debug log, so you can set the GSD debug level to like 6, and then you get 5 gigabytes of logs. That's great. You can find lots of information in there, but that's not very, if on an embedded system, that's not going to be fun. It's not fun to read these logs, so it's more like a structured way, so the computer can dynamically do stuff. Yeah, we don't know where we're going with that, but people want better debugging tools, and just actually seeing what your pipeline looks like. You can do that now. You can sort of dump a screenshot, but it's not dynamic. Doing that dynamically would be nice. All right.
Sounds interesting.
And tools like GDB also have the problem where GStreamer is completely multi-threaded, and if you have a huge pipeline, you can easily have hundreds of threads. Looking at that in GDB is going to be a disaster.
Thank you very much.
Thank you very much.
If you have any more questions, find us outside.
So